Okay, so we've got our maze solver done. I just did a video on doing an auto solver, which some people are going to do, and then our other kind of option here, you can do both, is going to be to do a class for handling the servos. And so this is a way that we can structure and organize our code so it's a little bit cleaner, so that we are less likely to make mistakes, and so that it's easier to read. And so the first thing we're going to do is we're going to create, and so a class, we have this library here, this servo library, and then we have this servo class, and it's got all these kind of things inside of it. So like when we write the servo, it won't let me go to that definition right now, but basically like this is the interface for this class. And so somebody wrote a bunch of code for controlling a servo, and they created this class for us, and this allows us to interact with the servo without having to rewrite all that code. And so that's one of the benefits of using a class, and so that's what we're going to do here. And our first step will be make some new documents. So we're going to make a new tab. We're going to call it servo controller.h. Okay, and then we're going to make another one called ServoController.cpp. Okay, and so we're going to implement it here, but this is what we call the servo.h. Controller.h is our implementation. And so we're going to start with our servocontroller.h. We're going to say pound if and def servocontroller.h undefine servocontroller, and then we'll say pound and if. Okay, and the purpose of all this is how we kind of prevent, essentially you can only include this file one time, but we will need to include it multiple times. And so we just have to make sure that if we include it here and here at the same time, we only use that include once. Okay? And so now in here, we're going to include our Arduino library. I don't know if we need this or not. I think we do. Just because we're in this different tab, and we'll also include our servo library. Okay, oops. And now we're going to make our class. So we're going to say class servo controller, and then we have in our class private or public members, which are things that we can interact with, like in our maze solver, and then we have private members, which are the things that happen like in the back end. And so here we're going to need to have our servo object. We're also going to need to have our input pin for the analog input. We'll use our int servo pin. I'll say int servo center. Okay. And those things I think are all we need for now. We might add some more stuff later, but now we're going to create what's called our constructor. And so this is the object we call when we initialize it, or the function we call. So we're going to say int input pin int servo pin int servo center and int input center and int max offset. Okay, so actually what we'll do here is we're going to add the max offset down here too. Okay, and so this function here, the servo this constructor, is the same thing as what's happening right here. Okay, except we didn't pass anything into it. Okay, and so now let's come to, we're going to do this. We're going to take this guy. Now we're going to come over to here. We're going to say pound include Arduino.h, pound include servo.h, and pound include ServoController.h. Okay? And now we're going to define this one, and then we have to tell it that it's from that object. And the way we do that is we go like this. Okay, we tell it it's from that scope. Okay, and so now we're going to do, so most of the stuff, let me add some, let me format this a little bit so we can read it better. Put all the arguments like this. Okay, and now we can actually do most of our work without even using the function. So we're going to put a colon right here. I'm going to say input pin. So we're going to define the input pin variable here with this variable here. This is basically a way that we can define all these just right on the initialization. And this is a kind of a standard practice for initializing a class. So I'll say servo pin. And it's possible that I make a mistake here because this is not something I do as often. Let's say servo center. Input center. And then finally, max offset, max offset. Okay. Let's go ahead and try compiling this. So we're going to include it here and include ServoController.h. And then what we're going to do is we're going to create ServoController x-axis, and then we're going to pass into it equals, I think we just go like this. And then it was, let me just copy it here so I have a reference. We'll go like this. Yeah, I think I have to go like this. Okay, so we're going to say x axis input pin x axis input pin x axis servo pin x axis or we're going to say x servo center x input center and x max offset. Okay, and now let's see if that works. Let's compile it. And nope, we do have a mistake. So I believe in here, yep, so we need to put in our ServoController.h, we do need to put a semicolon right there at the end of the class. And let's see if there's anything else. ServoController does not have a field named input center. Okay, so let's take a look here. Oh, yep, we missed it. So let's go ahead and add a variable here for the input center. Input center. Okay. So now let's see if we're good. And we're good. Okay. And so now we're going to do update servo position, and this function that we're going to call be a void function, and this is going to handle the servo movement. Okay. And so now, oh, first though we need to say our servo. So we're going to say servo dot, and so we need it just servo here, right? So servo dot attach pin. I think that's what it is, right? Or attach rather. And then we're going to pass into it our servo pin. Okay. And now we're going to implement this function. And so if we just try to do it like this, we're going to get an error. Okay, so if I compile this, it's actually not going to give me an error, but it's not going to do what I want. So I need to tell it that this is part of the ServoController class. And so to do that, I put this right here. Okay? And so now what we're going to do is we're going to do an analog read of input 10. Okay. And we'll say int input equals. Okay. And then let's grab this guy right here, our map servo function. Okay. I'm going to define this right here. ServoController map servo. I'm going to take all of these out except for input. Okay. And we do need to add in the direction, so we're missing one other thing. So let's add to here the input center, y max offset, and then we'll say x direction right there. And so here we've got to add it, int direction, and then right here, int direction. And I'm going to come over to here. I'm going to add it here too. Int direction. And then here. Direction. Direction. So we add that in. Okay? And now what we're going to do is, for this map servo function, actually, yeah, we'll leave that here. So we're going to say map servo in, we're going to say int map servo int input. Okay. And so now it's going to take that input and it's going to run it through these calculations, and it's going to return that servo position. Now we're going to say int servo position equals map servo input. Now we're going to say servo.write, and then we'll say input, or servo position. Okay, and there we have it. I think this will do it. Let's see if we made a mistake. Nope, I think we're good. So now let's come over to here, and we've got our servo controller for the x-axis, and let's do the y-axis as well. Let's just change these all to y's. Y and y. Okay, and then we're going to go ahead and comment out these lines, and we're going to comment out basically all of these. And then instead we can just say x-axis dot update servo position, and then y-axis dot update servo position. It might be helpful if we want to put these debug messages. What we can do is this. We're going to copy these into here. And we do this, and then we're going to say input position, and then we'll call this input. We'll say position, and then we'll say servo position. Okay, and we'll delete these ones. Okay, and then over here we will do serial.print x, and then we'll add this one right here, serial.print y, and then we'll add a serial.print ln here to skip to the next line. Okay, and so this takes up the space of this, and we've built our map servo function into here. And so now we don't have to be as careful about making sure all the right variables go the right places, because it's all handled internally to here in our class. Okay, and now let's test it. Okay, so I tested this and it didn't work, and what I realized was this. Alright, so previously, or what we had shown is this. So we had done this, where we did servo.attach in our constructor. The problem is the constructor happens before like runtime, and so we actually have to do this at runtime, where we where while the device is booting, that we have to or is already booted, that we call this servo.attach. And so we need to make an init function, so void init. So we're going to add this function right there, and then here we're going to say void ServoController, and then say init, and we're just going to take this here and cut it from there and paste it to here. Okay, and so that's going to attach to that pin at runtime instead of while it's booting, and then we just call it like this. And so we're going to say x-axis dot init, and init just stands for initialize, right? So y-axis dot init, and then it works. Okay, so try it out. If we want to also make this work with the auto solver, we can make another update servo position where we can pass in the position. And so we'll say, let's do this. We're going to make this right here that takes a position too. So we're going to say int position. And in this case, instead of reading the sensor to get the position, we're just going to write the servo position. And we're going to say servo center plus servo position, right like that. So if you wanted to, for example, use our auto solver, you still could. Where's our auto solver? You still could, and then except you would just say x-axis dot update servo position, and then you would just pass in this right here instead of this as well. Okay, and let's just verify that works. Nope, didn't like that. Update. Oh, we got to put it here too. So we're going to make another one here, void, and we're going to int position. There you go. Now it will work. Nope, still doesn't work. Servo. Oh, here we go. In here. Oh, this should just be position. Okay, now it will work. Yes, that works. Okay, so that way you can do that instead, and you can do that same thing for the y-axis. But really, it's up to you which way you use it. Okay, and so that's how you would build a class for controlling your servo, and it just kind of cleans up some of the control, puts the all the kind of heavy lifting back here, and simplifies, you know, the process of setting it up, because we only have to reference each of these individual values here, and now we don't have to worry about them kind of getting them all confused here every time through the loop. And we just call that update position. Okay, and so there you have it.